Hello everyone, it's good to see you all here. It's been really exciting to see the community grow over the past year, and it's kind of breathtaking to see all these beautiful faces here, and it all culminating in this event. So thank you for being here. And to introduce myself, hi, I'm Tim Smart, and I'm a founding engineer at Effectful, and my role is to just make Effect awesome, really. And you can find me online on GitHub and Twitter. Sorry, I mean X. And I also hover around the Effect Discord. So if you ever have a question, ask it on Discord and I'll probably answer. And today I'm going to talk about Effect's latest and greatest. So as part of my role as founding engineer at Effectful, is to explore the problems we are facing as developers and make sure discover the kind of problems that we face every day, the challenging ones, and make sure we have a solution in Effect that makes it easier in Effect Native. So today I'm going to explore a few problems, a few common problems you might face in your apps, and present you some solutions. So first up, one problem I want to take a look at is CPU-bound work. So in JavaScript, we're limited to a single thread. And one tricky problem with that is if you have a UI app, such as a React app or React Native app, and you want to, let's say, process an image, that's going to block the thread, and we can't have that because that will mean you have a janky app. So there are solutions to this problem. Well, you can't do this in React Native, but on a node server, you could have multiple processes. So what that might look like having multiple app instances. So if you orchestrate your app with Kubernetes, you could just spin up more replicas, or you could spawn a child process and communicate with it with RPC. Those are both valid solutions. Another one is you could use another language. Nice. You could use Rust. You could use C. You could use Zig and then compile it down to a node module or a native module in Bun. And just talk to it from your JavaScript app. And that's another perfectly valid solution. Or you could use workers. So in the browser, we have web workers. In Node, we have worker threads. And in Bun, you kind of had web workers. It's slightly different API. And today I'm going to focus a bit more on workers. But there are some problems with workers. And the first problem is there's a slightly different API for each platform. So browser web workers are slightly different to worker threads. They do share some common traits, but they are slightly different. And Bun is almost identical to the browser, but there's a few slight quirks. And the other problem is serialization. Trying to cross you can't just stuff anything down a message port. If you try throw one of your custom classes down there, you'll probably just get the class method is not a function. And this is the JavaScript runtime defeating you once again. We've all been defeated by the JavaScript runtime. And this is where I'd like to introduce platform workers. So over the past few months, I've been working on the platform packages that help make it easier for Effect to work across platforms. And as part of that, we've introduced a worker module. And this worker module aims to make it easier to use workers in Effect by providing the same API for every platform. So if you're in the browser or in Node or in Bun, you just implement the same code everywhere, and you just provide a different, kind of like a different implementation layer to it. And it supports Effect Schema that we all know and love. Well, hopefully you all know and love it. You should go and love it after this. And it supports response streaming. So if you need a kind of like a long-lived response coming back, you can stream it back, and it just works. Oh, and it has tracing for free. And who doesn't love free stuff? So first up, I've mentioned it supports Effect Schema. And the first thing you need to do to use workers in Effect is to define some requests. So there's a bit of code here, but I'll step through it. And you can see here we're importing from the schema module and the platform module. But first up, we are extending a tagged request-based class from the schema package which gives you a lot of stuff out of the box. But to create one of these, first you pass in a string tag. And we need this so as the request goes over the wire, the other side knows what kind of request it is. And then we get type-safe errors, which is a killer feature in Effect. But also what's cool to note here is it's fully serializable. By using schema.taggedError, you get serialization for free. And we move down and we pass in a success schema. And here we're using the transferable module from the platform package. So what transferable does is it automatically kind of like takes the array buffer that backs the image data, and instead of copying it over to the worker, it will just be, I think it's just shared, but it uses the WebSocket transfers API under the hood. And then you need the request parameters. So the worker needs to know what to do. So this is the data we're going to give to the worker so it can crop the image. So it'll crop the image and then give back the cropped image data. And once you define multiple requests, we're just defining one here, but you could define it as many as you want. We create a union of all of these requests and kind of like package it all up into a single schema. And we also extract the type for it. So once you define your requests, you can start implementing your worker. And here is the code for that. We'll just quickly step through it. So first you create a layer using the layer serialize function, and you pass in your union of schema requests, union of request schemas. And then for each request in that union, you implement it. And here we're just using a fake crop function. And then if you had more requests, you would also add that in here. And then what's key to note here is this is completely platform agnostic at this point. So we can still see here that there's a missing dependency. And that is that dependency is the platform that we eventually provide it with the platform we are targeting, which I'll show you in the next slide. And if you strip away all the types I just added there so you can see what was going on, it's actually quite concise, easy to read, and gets the job done with quite a few lines of code. So if we run the worker now, first we import that layer we just created. And then this is the key part. We're providing the kind of like the browser implementation of workers to our worker. And that will, under the hood, use web workers and run it for you. And then you can just run it using layer.launch, or you could use effect.run fork. But run main is quite a cool part of the platform package, and it will just set up interruption for you. So if the attempts to detect if the browser window was closed, the browser was shut down, and like cleans everything up safely. So at this point, we've got a fully working kind of like worker runner. And now we do implement the client. And for the client, we use this makepool serialize function from the worker module. And at this point, you can pass just the type of your union. So it doesn't actually, you can actually tree shake. So if you have 100 requests and only use 2 of them, the other 98 schemas what get in your bundle. And then we can pass in the size of the pool we want. So you could also use something like the number of CPUs here. I think in the browser you can use navigator hardware concurrency. You can also use min size and max size if you want to have like an auto scaling pool. And then once you've created your pool, you can just start sending requests to it. Easy as that. And then last step is to provide the platform you're targeting. So here we're targeting the browser. So we provide the browser layer and we tell it how to spawn a worker. And just like that, we have an end-to-end type-safe worker implementation in Effect, and it supports streaming, and you get tracing for free. And who doesn't love free stuff? So the next thing I want to tackle is very similar. It's type safety over boundaries, but in this case it's network boundaries. And this is quite an important problem when you want to have a full kind of like full stack Effect application, but you want to have type safety from client to server. So if you have an API, you could use something like an RPC package, and then you could get end-to-end type safety. There are solutions already. If you Google, there's like 50 different RPC libraries. Probably one of the most popular ones right now is TRPC. But they all share some common issues. They're not actually end-to-end type safe. Shock horror. TRPC is actually only really does, well, basically the schemas aren't bidirectional. So if they have a schema for the request coming in, but for the response going out, you can't really use like a custom class or custom data types. They try to get around it with things like super JSON, but it only supports JavaScript primitives. And pretty much every RPC library out there kind of shares this problem, but as we mentioned before, Effect Schema supports bidirectional schemas. So it'd be really great if we could use that here. And this is where I'd like to introduce Effect RPC. It's built for Effect, that goes without saying. It supports bidirectional schemas. And one key thing to note, it uses Effect Request Resolver under the hood. And a request resolver is in Effect one of the more powerful primitives we have for sending requests, and it has out of the support for batching, and it's also a composable primitive in Effect. So you can do things like, I'll talk a little bit more about this later, but you can do things like transform it to kind of like limit the batch sizes and all sorts of amazing, wonderful things. And then also RPC also supports response streaming. So if you have a long-lived response, it also works for that situation. And it has tracing for free. And who doesn't love free stuff? And again, it's very similar to workers. You define your requests, but probably the main difference here is we don't need to define our union. So again, you have the string tag, error type, success type, request parameters. And then this is where it starts to get different. Here we're creating an RPC router, and we're passing in a procedure call that returns an effect, and we get the user ID and return a new user. Very simple. And then at the end, we extract the type of our router, and so we can then use it to derive a client. And then we can just add it to a platform HTTP server. We can use any endpoint we want as long as it's a post endpoint. And then it comes with a module to convert it to a request handler. You'll route it into a request handler. And then at this point, we have a fully working server. And for the client, we can use our router type we extracted earlier. So the key thing to note here is that it's importing the type. So when it gets compiled into JavaScript, it gets completely erased. So your server doesn't get into your client, which would be bad. And then we're using a make client function and just passing in our endpoint. And make client is actually quite a simple wrapper. Behind the scenes, it's creating a request resolver, which is quite a powerful primitive, as I mentioned earlier. And then in the next slide, I'll show you how you can create a request resolver if you want to use that. But once you've created your client, you can just start putting requests into it, and you'll either get the stream back or the effect back, depending on what type of procedure call it was. And then here, this is the more kind of like low-level API. You can create a request resolver. And the key things to note is we're passing in a custom HTTP client here, and we're setting the URL. And then you can like stack on things like retry policies or error handling, whatever you need. So if the connection goes down, it retries exponentially. And then there's this API resolver.toClient that converts it into an easy to use client. And at this point, you have an end-to-end type-safe RPC solution in effect, and you get for end-to-end type-safe, it's bidirectional schemas. So any schema you use will work with it. You can shove down your custom data types, and you get tracing for free. And I sort of started covering off request resolver here, and I mentioned that they're really powerful primitives. So I want to dive a little bit deeper into that and show you some of the new things we've added that make request resolvers and a really amazing tool in your toolkit. And the first problem with request resolvers that I want to tackle is batching across contexts. So by default in Effect, you might not be familiar with request resolvers, but they give you batching for free. But the problem with the batching implementation and request resolvers out of the box is it only happens in a single execution context. So if you send off 100 requests in one location and then 200 requests in another location, they will actually still send off two batches. They won't get joined together. And we want to join them together in some situations to cut down on API calls and the underlying resource, or there's a myriad of reasons. So one thing we want to get in our apps is the data loader pattern. And this is where a new package called Experimental in Effect, we've added to Effect. And don't let Experimental scare you too much. But in the Experimental package, we have a request resolver module. And in the request resolver module, we have a couple of functions to help you out. And I'll show you a quick example. So here we're importing a data loader function. And here, I'm just using the request resolver that we created in our RPC example earlier. And then with a couple lines of code, we pass it into that data loader function, give it a time window and a max batch size. So we can say, within 100 milliseconds, regardless of where the requests come from, add it to the same batch. And so regardless if you send off 100 requests here or 200 requests over here, if they both occur in the same time window, they get added to the same batch. And then max batch size, so if that batch ever exceeds 1,000 items, it will get sent off immediately and a new batch would start being created. So with a couple of extra lines of code, we've taken a request resolver without this kind of data loader functionality and then transformed it into this new request resolver. And kind of building on top of that, the last problem with request resolvers I'm going to tackle today is persistence. So it's really great if you send it, it's really great if you get all this batching stuff, but wouldn't it be great if we could cache between app instances or app restarts? And this is really helpful when you have more than one app running. So if you have more than one replica, or you have like a CLI app that is short-lived. So if you spin it back up again, you want to make sure like your cache is still warm. And again, in the experimental package, we have this new persistence module. And what this aims to tackle is, serialization, it aims to tackle like storing results for your requests. So it's built on Effect Schema again, and it has several adapters. So we have in-memory, we support the key value store module from the platform package, we support LMDB, and there's plenty more to come. Eventually, we'd like to add things like Redis or Memcache, and then add options to like set the time to live and max capacity. And I'm sure I'll get to that over the next couple of months. And again, to use this, we define our requests like earlier, but the key difference is we add a primary key. And this primary key is used to identify it in the underlying storage. And then here, we've got an example of using it with a request resolver. So again, the same request resolver from our RPC example. We pass it into this persisted function from the experimental package, and then we give it a store ID. And that store ID allows you to have multiple resolvers using the same storage backend. And then once you've done that, you just need to provide the storage implementation that you want to use. So here we're going to use the key value store from platform package, and we're just going to store everything on the file system. So with those extra 3 lines of code, we now have a request resolver that is fully persisted between app instances. So regardless if your app restarts or it's in a different place, they all share the same storage backend. Cool. Well, the last thing I'd like to look at today, the last one I'd like to look at today is observability and development. So tracing and metrics is all cool, but it's really hard to get a good stack set up in development. It takes a bit of work, a bit of fiddling around. Docker and stuff makes it easier. So yeah, Docker, Tempo, and Prometheus is one thing you could do. Like a lot of people just have a Docker compose file and play around with it for a few hours to get it just right. But again, it's still something you have to add to your development stack. It's a bit of a pain in the ass, let's be honest. Or you could console.log, which is a bit lame. It's great for small things, but we're better than that, guys. So today I would like to announce something we've been working on, and that is a VSCode extension for Effect. So over the past couple of months, we've been hacking away at this in the background. And the thing we wanted to solve with it is just making it really easy to, I mean, Effect has great tracing and metrics. I mean, if you've ever tried to use OpenTelemetry in just a normal TypeScript project, you've probably, everyone's like, why are you swearing? But with this VS Code extension, we want to make tracing really easy in Effect apps. And we also want to make metrics really easy in Effect apps. And we also want to make it really easy to debug Effect apps. So if you like set a breakpoint somewhere, we want you to be able to inspect the context of your Effect application. To quickly show this to you, actually, oh yeah, it's all inside VS Code, so you don't have to leave your editor. Now just make a quick note that this is early alpha, so it's very early, and we plan to add more features in the future, like visualization and other things, but I think we've got enough now to like make developing Effect apps even easier. And to show this to you today, I'll give a quick demo. Just going to test this mic. Yeah, it's working. Full screen. Right, here I've got a little app I made just to show this off. And we've got in here, just going to move this a bit, HTTP server. And the key thing to note here is this new thing. All good? Just fixing the mic. Bear with us. Is we're providing this DevTools layer. And this is the only thing you need to add to start using the Effect DevTools, which is what we've called the extension. And this DevTools layer can be found in the experimental package. So I'll have a quick look at the HTTP app so you can see what it does. There's a single endpoint, and in this case we're using an RPC server. And then we're just listening, providing some dependencies, listening on a really good port. And then we're defining an RPC router with two endpoints, two procedure calls, one that streams back a list of user IDs. And then we've got another procedure call that, for a given user ID, gives us back a user from the user repository. So having a quick look at the user repository, we can see two methods here. We've got a find by ID function, which given an ID will give us back a user. And then we've got our all IDs method, which returns user IDs 1 through 10. But the key things to note here is we've added some metrics. So up here I've defined a few metrics that we can use. And we're tracking things like the duration this took, if it was successful, or if it failed. And then we're adding a tracing span, and this adding some attributes to that span. So that kind of tackles the server side of it. And if we have a quick look at the client, it's pulling out our RPC client from the context, and it's streaming back those user IDs. And then for every user ID that it gets back, it's fetching the corresponding user. It's also worth noting that this RPC client is using that data loader function from before, so everything will get sent off in a single batch. And then for every user in the stream, it will just log it to the console. And then down here, we're also providing the DevTools layer to our client. So it also supports merging server and client spans into the same VS Code extension. So if we go over to, sorry that I put my sidebar onto the right. Some of you will probably be triggered by that, but that's fine. So first thing we'll do is we'll start up our DevTools server, and we'll open a terminal. I forgot to ask if you could see that at the back. Is that all right? The text size, brilliant. Thank you for that person that nodded. And I'm going to open up a debug terminal, which is a great feature of VS Code. This allows me to start a server, and it also attaches the debugger. And over in the debugger, you can already see this new tab here called Effect Context. So if you ever hit a breakpoint, that will get populated with the contents of the context. So we'll switch back to the DevTools and close this clients window. And we can already see in real time metrics streaming in. Here we can see the fiber count going up and up and up. And that is actually the DevTools itself polling for all these metrics. But we can't see any traces yet, so we'll fire off some requests by running the client. Cool, so we've sent off our requests, and then immediately we can see some traces coming in. So there's the RPC request that streamed back our user IDs, and we can dig into it. We can see it left the client, hit the RPC router, and then hit the user repository, and we get all the timing information, and then you can see all the trace and span IDs there. And then for every ID, this is because everything got batched together. The stream was a single HTTP request, so we can see that there. And then for every ID that came in, we can see it. It came in as a request, and then again there's the user repository span, and there's the span attributes. So it's like a really quick way of getting your tracing information into your editor. And then if we jump down to the metrics, we can start seeing some results come in. Earlier, you may have noticed that it failed when the ID was greater than 10. So I've just kind of simulated failure here. And we can see that failure come into the metrics. We had 10 successful requests, and we can see how long each request took. So that's tracing metrics quickly. And the last thing we'll take a look at is the context inspection. So if we go into our user repository and set a breakpoint somewhere, maybe here, and then we'll fire off some more requests. Great, it worked. And straight away we can start seeing all the dependencies in our app, as well as the default dependencies that Effects adds for you. So we can see here we're in a scope, and scope and effect is for resourcing. We can see all our platform dependencies here. Here's our user repository. But more interesting is you can see things like the HTTP request that came in. We can have a look at the headers. You can look at the URL, or you could even look at the JSON body that came in. So it's really useful if you're like in the middle of Effect app and want to set a breakpoint and see all the information at your fingertips. And I keep pressing resume. Yeah, keeps coming in. So hopefully from that you get like a quick idea of what the VS Code extension can do. And you may ask, when can I use it? Well, why don't we just quickly publish it? This is going to be really boring because I've set up CI, but I'm just going to merge the pull requests. And so if CI doesn't fail, it will be available in 15 minutes or so. It will probably fail. Cool, so that concludes my talk. Hopefully you saw something today that might interest you or something you might be able to use in your applications. There was a lot. I covered that really quickly, so I don't expect it to have sunk in. So if you have questions, just tap me on the shoulder. I'll be around for the whole conference, and ask away. So again, great to see everyone here. Happy effecting.